Today's lesson is Properties of Operations, and the standard is NS 7.1D. Apply properties of operations as strategies to add and subtract rational numbers. So your learning goals should be across the top of your page, and you should always already have your interactive manipulative taped into your notebook appropriately. Hopefully these are all strategies and activities that you have gone over before. However, if they're not, this will be new for you, and you may want to watch the video a second time, paying close attention so that you have all the appropriate notes. Okay. The first property that we're going to talk about is the commutative property, and I like to think about that as the flip-flop rule. It's when you're allowed to flip the order of numbers, and you'll still get the same answer. So what I'm going to do is I'm going to flip up that commutative rule flap, and I'm going to write my notes underneath it. Okay? So across the top, we're going to start with a variable expression, which will be written as A plus B equals B plus A. This is what's known as the rule. So because I'm using letters instead of numbers, those letters can represent any number in the world, right? If I say 17 plus 3 equals 20, then 3 plus 17 should equal 20. If I say 2 plus 5 is 7, then 5 plus 2 should be 7, right? In this expression, the A's are the same and the B's are the same. So this rule will always be true. The rule is you can flip the order of your terms and not affect your solution. Now, let's do two examples here. We can talk about 2 plus 3 equals 5, and 3 plus 2 equals 5. These things are both true. My rule applies. The second example I can use is 1/2 plus 5/6 equals 8/6. Well, 5/6 plus 1/2 also equals 8/6. So again, my rule applies. It is true. It will always work. This rule applies to addition problems and multiplication problems, not subtraction or division problems. So you may want to write that down. You can add and you can multiply and provide these rules, not for subtraction or division. So I'm going to close up my flap. And I'm going to move on to the associative property, or the buddy rule. The associative property says that we can group numbers in a certain way in order to not necessarily change their order, but change the order in which we do things. So the rule that I'm going to write is A plus B plus C equals A plus B plus C. And keep note that when we use these bracket things, what that means is that you're going to do this part first. So the associative rule doesn't necessarily change the position of the numbers like the commutative rule. It changes the order in which we do things. So you can rearrange the grouping of a problem without affecting the solution. Let's do an example. I'm going to use the numbers 2, 5, and 3. So 2 plus 5 plus 3 should equal 2 plus 5 plus 3. Now, the grouping, again, the parentheses mean that you have to do that piece first. So 2 plus 3 equals 5. 2 plus 5 equals 7. I couldn't read my handwriting. Plus 3 equals 10. On this side, 5 plus 3 equals 8. Plus 2 equals 10. Both of these sides are equal, so my rule is effective. Once again, this is only the case for addition and multiplication. You may add or you may multiply numbers and use your associative property. The last rule that we're going to talk about is the identity rule, or the me rule. And the identity rule is different for addition and for multiplication. So we're going to have two specific rules here. So when you're adding and then when you're multiplying. The identity rule when you're adding says A plus 0 equals A. If you think about the name here, the identity, when you have an identity, it is who you are and it remains who you are. So if I have any number and I add 0, I will still have the original number that I started with. An example of that could be 4 plus 0 still equals 4, or 3/5 plus 0 still equals 3/5. So both of these examples show that the identity rule allows you to add 0 and not change the value of your expression. You might be thinking, why would I want to do that? Sometime in pre-algebra and algebra, you are going to want to do that, and it will be very useful in order to perform an operation but not change the values of your numbers. So think about if I had a number A, and I want to multiply it by something to keep the same value, you would do multiplication by 1. So an example, 7 times 1 still equals 7. And 2/3 times 1 still equals 2/3. So again, that there are two rules in this category. One for addition and one for multiplication. So those are two rules that you are going to have to remember. I would say that this is only applicable for adding and multiplying, but it's actually not. The identity rule can also be subtracted. If I have A minus 0, I still equal A. And in terms of division, you can always divide a number A by 1, and you will still get A. Quick example, 6 minus 0 still equals 6. And 12 divided by 1 still equals 12. So you actually get bonus rules here. If you can remember your addition and your multiplication rule for identity, you can also remember your subtraction and your division rules. Oops. So to finish up today, you are going to have a quick proof. And remember to type and include your what I learned, your proof, and your reflection. I have an image here of what my paper looks like, so hopefully that will help you to figure out what your paper should look like. The proof says which property of multiplication is shown. There are a few examples here. Which property of multiplication is displayed? Which equation shows the identity property of multiplication? So you're going to have to tell me which property is being used and why.